This chapter, we are going to basically discuss on the importance of groundwater in engineering geological point of view. For example, if what kind of groundwater characteristics are important for a civil engineer in terms of the construction practices. So we hope by the end of today's session, you people will be having an idea that what are the different terminologies using in groundwater and which are related to the engineering practices or the civil engineering practices. Okay, so first of all, this is what we have already discussed, the water cycle. From evaporation from the sea, it goes to the condensation, then it goes to the precipitation, then water goes to the surface, some water infiltrate, some water flows. So surface water, groundwater, so we roughly call this as a groundwater that forms around 0.76% of all the waters which is existing on the crust or in the surface of the earth. Now if you go to the underground water, so underground water is what? The water which is present below the surface of the earth. So this underground water, we have discussed, there is something called a water table. That is where the underground water is in equilibrium with the atmospheric pressure. So water which is penetrating from the surface, which goes to this layer, and below this water table, the water will be saturated in nature. So there are two zones basically which are present here. One we call it as the saturated zone, and the other one we call it as the unsaturated zone. So in the unsaturated zone, the water will be moving downward, and once it reaches to the saturated zone, there would be number of different kind of movements in the downward and the horizontal movements of groundwater. But if you see here in detail, in the groundwater zone which is saturated, and whereas in the upper portion, that is unsaturated zone, there are different two varieties of other kind of water saturations or water presence. So we call it as the Vadose water and either perched water. So if you see it is groundwater and the Vadose water, the water which is below the saturated zone, we call it as a groundwater. Whereas while going, the movement of the water from the surface to this saturated zone, through this process, some amount of water which will stored in this part, that is in the unsaturated zone. So the water which is remaining in the unsaturated zone, in the porosity zone, the cavities which is storing in the cavities of the soil, we call it as a Vadose water. Other than that, the other form of existence of water which is below the surface, we call it as a juvenile water and connate water. Juvenile water is the water which is originates from the molten magma. If you remember the Bowen's reaction series and the process of formation of rock in the chapter Igneous Petrology, we discussed that the magma is a mixture of so many different number of chemicals, and there is a major amount of water is also present in this system. So this water which is present in the magma, as a process of cooling, the rocks will form, but the water which is present in this magma, what we call it as the connate water, so or the juvenile water. So that water will enter into the rocks which is below, maybe they're on the hard rock, on the fractures or the cavities which is present in the hard rock. So that kind of water we call it as a juvenile water. So the age of this water may be very, very old at the stages of formation of the igneous rocks, or it is formed from the magma. Other than that, there is another stage of water which is connate water, that is coexist with the igneous and sedimentary rocks since its origin. Okay, so the rocks which sometimes preserves, if you remember the story of formation of sedimentary rocks, the rocks which the say soil or the sediments which deposits, and as a continuous process of lithification, compaction, lithification, and pedogenetic processes, all these different processes which convert that soils into a rock. And this process of converting the soil into a rock, some amount of water which trapped inside the rock, then we call that kind of water as a connate water. So these are the different forms where the water exists on the subsurface. Now if you see some of the other facts about groundwater, we have basically discussed these things in the earlier time also. The water table is not a flat surface. This we have discussed. The water table, what we see here, this is the water table, that is the layer. Below that, the water is saturated, and above this layer the water is unsaturated. So if you see, the water table is not a flat surface which roughly take the topography of the area. That means if you see, the configuration of the water table can be measured by plotting the water level at several heights. So if you plot a water level at this point, if you plot the water level, find out the water level at this point, if you find out the water level at this point, so the highest point of water level we will find it at the point which is below the hill, and the lowest point will be near to the recharging points or near the rivers. So we can easily find out a height difference between these two areas. That is the highest point, which is at where the water table at the hill, and the lowest point, which is at the water table at the recharge point or at the river valley. So this difference we call it as the hydraulic head. Understanding the hydraulic head of the water table is very essential for any kind of construction. So for example, if you are going to construct a dam here at this elevation, the hydraulic level of the water table is higher than that of the height of the dam. So that is a good condition. So if in other case, if you are going to construct a dam up to this level, this height, so the water level which I am going to store water in this dam, which is much higher than that of the water table. As a result, what happens? The water in this will go into that soil, so that will saturate the soil first. Then only the remaining water will only be storing in the dam. So this is the factors of the configuration of the water table. Then we have something called as soil water. The soil water is the water which is remains inside the voids in the soil. Okay, so this is the soil which is bedrock, and above that there is a soil. So the soil which is remain in these voids of the soil, we call it as a soil water. So in the zone of saturation where soil water moves freely under the influence of gravity is called the free water, and whereas the amount of water which is stored in the unsaturated zone while it is moving below, we call it as a held water. So the water, it's nothing complicated. When the water which flows on the surface, some amount of the water which started infiltrating downward, and this process of infiltration to the downward, the water will reach the saturated zone, and the water which is present here, that will freely move to the downward direction due to the process of gravity, so that we call it as a free water. But the water which is moving on this part, which is further on the downward direction, but while it is somewhere it is holded some amount of water, that we call it as a held water. So these all terminologies could be shared in the so the calculation, the amount of water which is on the unsaturated zone, the amount of water which is on the saturated zone, the porosity, permeability, all that parameters would be very essential for a civil engineer to understand before considering the foundation. Because keeping the foundation at what level? For example, if I'm going for a construction, and my construction foundation I kept on this part, and just below that I'm having a capillary part. Capillary fringe is the area where the groundwater is penetrating through this capillary rise. Okay, so this capillary rise, when I put a more pressure on the soil, then the capillary rise will increase, and the water will penetrate more and more into the soil, and that will reduce the capacity of the soil bearing capacity. So it is better if you understand the exact level, and if you keep it directly below this, then what we get is the expected amount of soil bearing capacity. So there is chances of change in soil bearing capacity in the as a result of capillary rise of water is less. Okay, so these are other terminologies which are associated with the soil water. Now there is some other kind of water, so the water which is present in subsurface, we call it as the structural water. So this structural water is nothing but the water which is present in the crystal as a process of formation of the crystal. So this water will never come out. This water will remain in the crystal only. Under sand, until we melt and we try to put a lot of effort to extract the water from the crystal, it will not come out. So that we call it as a structural water. And the water which is hiding soil can freely absorb a part of water from atmosphere moisture by physical forces of attraction. So the water remains in soil as tightly bonded water by force of adhesion is known as the absorbed water. So water, the moisture which is there on the atmospheric moisture, some part of this atmospheric moisture will be absorbed by this soil, and that kind of absorbed water we call it as the hygroscopic water. Then we have a capillary water. This is what I have just discussed. The capillary water is the amount of water which is rising in the water table, which is just in the boundary between the saturated zone and the unsaturated zone. We call it as the water table. So there would be a small region where this above the water table, the water from the saturated zone will move upward through the capillaries. You know what is the capillary rise? The fluids which is moving in against the gravity through the small voids. So that is the capillary rise. So that capillary rise where the water is present in this region, we call it as the capillary water. Okay, so these are the main soil water, the water which is going to be present in the soil. Then there is few more concepts which we call it as the confined aquifer and the unconfined aquifer. Before going to the aquifer, let us see what is aquifer and the aquicludes. So there are two terminologies which will be mostly presented in the geological reports, so that may refer the aquifer and the aquicludes. These are nothing but the aquifers are the layers or the rocks which are having high amount of porosity and which is having a very good permeability also. Okay, what is then the porosity and the permeability? Porosity is what? It is the measure of capacity of a rock to hold the fluid. So it is actually the amount of cavities which is present in the rock. So if you consider this block as a rock, so this rock is having the cavities over here. So if you see the cavities over here, these are all connected. So this we call it as the permeability. The amount of cavities present in a rock is called the porosity, and the interconnection of that pores is called a permeability. So in this case here the permeability is high because these are all interconnected. But if you see here the rocks, when water comes here, it is now blocked. It is not having a very proper way to go. So the permeability on this is less. This is less and this is more. And here it is there is no permeability. These are all interconnected, unconnected cavities. So water which is entering into this will not transfer. Okay, so this will have a less permeability compared to this is having, there is no porosity, but this is having permeability because of the fractures in it. So water can penetrate to this. If you want to see the porosity of the water, take a beaker, fill that with some amount of sand, full amount of sand. Then you add water into it. So water will go into that. Some amount of water will go into it. So you found out that how much water is going into that till the top of the level of the sand layers. So the amount of water which is going into that cavities or that is what we call it as the amount of porosity, that is the void spaces. Now you calculate, you continuously pour water into this and you give an outlet and measure when you put 1 liter of water here, that how much time it is taking for the water to go out of this and how much amount of water is moving on per centimeter, how much is the movement of water in this layer in centimeter per second. So that will give me the permeability. So that is the measure of amount of water, the easiness of the water can be moved through that pore spaces. So this is what we call it as the porosity and the permeability. And if the rock is having a porosity and permeability both, that means the water which is entering into the void spaces can easily pass through the rock, then we call it as an aquifer. We call it as an aquifer. But if the water is having porosity but no permeability, then we call it as a aquiclude. The best example of an aquiclude is a clay layer, clay. So if you take clay, the clay, and if you put water into that clay, means that the sand size, you remember less than 63, less than 63 or 263 microns, the fine grained sediments or the clay that we use for the preparation of the potteries. So that clay, if you put water, if you add water, water will go into that. We can add the good amount of water, so that means it is having porosity. But if you keep that water to drain out of that clay, it will not drain. It will remain in that only. So the what is lacking on that clay? That is the permeability. So clay is not having permeability, but will have a high porosity. So that kind of materials which is having a high porosity and there is no permeability, we call it as a aquicludes. But in some situations, these aquifers are going to be two different varieties. We call it as confined aquifer and unconfined aquifer. Why is that confined aquifer and unconfined aquifer? See, here if you see this layer where the water is able to move, and above there is a layer which is not aquifer. This is not aquitard. It is not having a porosity and permeability, so the water cannot move up. It constrains the movement of the water. So as a result, what happens? The water bearing layer is sandwiched between two aquicludes or aquitads. The aquitads is also a terminology used for the rock which is not having the capacity to move water. It neither have porosity nor have permeability. So this kind of layers, if the water bearing layer is confined, we call it as a confined aquifer. And if it is the other way, that the upper layer where there is no aquifer, there is no sandwiching, so only one, the upper layer is open, we call it as a unconfined aquifer. So this confined aquifer situation usually create a condition, we call it as the artesian well condition. What is that artesian well condition? Here if you see, this is a confined aquifer. Why is it confined aquifer? So there is a layer which is impermeable, there is another layer which is impermeable. So water is not able to move upward, and if you see the hydraulic gradient or the difference in the height of these two regions, the height at the hydraulic head is up to this level. Now in this condition, if I make a borewell in this area and if it reaches my confined aquifer, the water can easily flow to the surface without having any effort. We don't need to put any water pump, because it will automatically flow through this well. What is the reason? Because the reason is that the hydraulic head of this area is much higher than that of the head of this well. Or if you see, this is the same thing, what we call it is the artificial conditions in the water tanks we make in the cities. We keep a water tank which is much higher than that our levels, our house water tank. So the water from here will automatically flow through this. So this is the same condition. This is an artificial condition and this is a natural condition which is existing on the surface. The water which is below the surface, which doesn't stay there only, that it also moves in the condition in the subsurface. So the movement of the water is usually from the upper elevation to upper height to lower height. Rather, it also moves in the horizontal way. So these all movements are depending upon the amount of water which is present, the number kind of structural features like the porosity, permeability, faulting, joints, fault, unconformity, all these structural features, whatever we have studied in the previous sessions, will be controlling the movement of water in this region. So having a clear picture, having a clear understanding of the movement of this water and its structural features are very essential for any kind of major construction we are going to do in the region. How to do that? We'll always have a geologist to help you in that process. But the civil engineers should understand the importance of knowing the facts of groundwater movements. So the all kind of joints, fractures, fault, porous and non-porous layers, all these things together will be controlling the movement of water. So this water will be moved, and when we are different processes to study the characteristics of this water, and finally we will be preparing a groundwater map. So the study of this groundwater, we do it in a basin level, where we identify where is an aquifer present, what are the preparation of water table maps using the aquifer. So we will be studying the relation between water and the surface water and the groundwater, how much it is penetrating, how it is penetrating. Then we'll be discussing or determining the hydraulic characteristics of the aquifer, then the study of problem of saline water intrusions to that area. So these all characteristics we'll be studying in the basin level. So that is the systematic groundwater investigation. Then along with that, there are areas where the water, there are areas where the hard rocks are exposed. There also we study the characteristics of the groundwater. There are major portion of the part of our country is covered in the hard rock terrain. So we need to study that the area which is covered in the hard rock. So in the hard rock areas, how the groundwater occurs and where it is occurring, what kind of fractures, where is the rhyolite, which we call as the weathered profile. So all that details will help us to understand the movement of the water, and then we prepare a groundwater map. So these groundwater maps will be available. So if you search for a Geological Survey of India site to find out the groundwater map, so you'll get a lot of information about the characteristics of groundwater. And there is another body which basically look into the groundwater characteristics, which is the groundwater board. So they also do the systematic mapping of the regions, the entire country they do, and they will be preparing the variations of the water table during the summer, during the winter, during the monsoon, how the water table moves, how the groundwater table changes, what is the amount of saline intrusions. All the details will be studied, and we will be preparing the groundwater maps. So similarly, like the contour map or the geological map, we get another map which is called the groundwater map. So that informations are also helpful for a civil engineer to understand the basic characteristics of the groundwater characteristics of the region. Influence of underground water in engineering construction. So here in this case, we are not going to discuss all the engineering constructions or all the civil engineering constructions. Rather, we will be concentrating more into the typical or the important or major engineering constructions, major civil engineering constructions like dams and reservoirs. Then roads. When I'm talking about roads, I'm not talking about the roads which is of a city road or a state highway. I'm talking about the roads which are going to be constructed in tough terrains, like the roads, the one which are constructing in the Himalayan terrains. Then the problems in tunneling. So tunneling is another important aspect. In the recent news, if you heard that the Atal tunnel, which is constructed in the highest and the longest in India, is longest tunnel constructing at this level of height. So that kind of engineering marvels what we are basically interested in. So that tunneling what we need to take care, so that would be another topic. Then there are few water retaining structures. While considering this kind of structures, it may be a reservoir, it may be a large lake or an artificial lake, or any kind of water retaining structures when you are going to construct. So what kind of geological parameters are going to affect? Or what kind of geological parameters, basically the groundwater point of view, we are going to discuss in this chapter. Okay, so the first one, let us take the dam and reservoir. So if you take the dam and reservoirs, the major important factor which is going to affect the stability of a dam, it's the capillary rise area. If you remember this image, this is the same image we discussed in the previous slides, where there is a saturated zone. Above the saturated zone, there is a small region where there is a capillary rise of water, groundwater, which penetrates into these pores or this facility. So above that, it is a unsaturated zone, which is the water flows through, that comes through the groundwater through these processes. Now, if I'm going to construct a dam, and if I am going to place the dam under this condition, that is, the basement of the dam is now just above the capillary fringe or the capillary region. So as a result, what happens, the pressure which is going to exert on this part or in the bottom of this, that the pressure will increase on this part, and it will increase the capillary process, the rise of the water through this capillary rise, and along with that there would be the movement of water. Seepage pressure of the groundwater flow may take place below an earthen structure. So this structure what you are going to construct is going to create the trouble, and this the seepage pressure and the capillary rise pressure, which will together weaken the strata under this condition, and that may be a different, that will get to the water into a different condition that what we perceived during the geotechnical characterization. When we are studied during the geotechnical characterization, the water is going to be in a dry soil, but when the water structure is placed on that particular soil, so the exerted, the increased capillary rise and the movement of the seepage water, that together reduces the stability of the water, stability of soil below that. The bearing capacity of the soil may reduced by the activity. So as a result, the structure may fail unexpectedly. So that is one thing. And the second thing is, so as a result, the best way is that to overcome this difficulty, the best way is to place the sediment, place the structure comfortably in the area of saturated zone. Avoid the areas which is unsaturated and is very close to the capillary rise zone. So place it safely in the part where that is a saturated zone. Then the water, even if it is moving, the water seepage and all, it is already having the stability what you are expected in the geotechnical or geological study. So that will be more that will give more stability in point of the structural characteristics. Another important aspect is the structures, the rocks under the dam site may have different kind of structures. So these all structures whatever we are getting here, because if you are going to construct a dam here, and if this is the dam which is constructed over this part, so this part will become a reservoir. So water which can go through this seepage, it can go to this and it can come here, so it can connect to this structure, then it may come out of somewhere here. So this kind of different processes are actually affecting on the groundwaters. Now the next is the rock type. So porous sandstone, if you have a porous sandstone and which is having or which is overlaid by a shale. So as you know that earlier we have already studied, shale is having high porosity, but it is having very less permeability. So this kind of intercalated sequences, the sandstone and the shale intercalated sequences, where the water may move through this contact between the sandstone and the shale, because the shale is not allowing the water to penetrate, it is not allowing the water to pass through. As a result, there will be a lateral movement it is possible to happen in the contact between two different rocks. So this seepage take place through the interface sandstone and shale. So it is a best idea that to avoid this kind of situations, or do the proper treatment before considering this kind of areas. Lastly, that the solution activity. If you remember, we discussed about the karst topography. When you are do a construction of any kind of structure in the region, and some amount of water will be penetrating into the soil through these small fractures or between the joints or any other part. So as a result, if the water which is penetrating and the region below that is having a characteristics of soluble effect, means if it is a limestone, as you know that it is very easy to erode with a right amount of acidity. So these limestones can be leached by this entering water. So studying this nature of the characteristics of the soil, how soluble that in water, and that parameters needs to be studied, and that is another effect of the construction, another effect of the groundwater which is affecting the stability of the structure. Okay, so these are basically about the characteristics of the dams and reservoirs. Now if you look into the road, as I already said that the road, when you are talking about, I am not talking about the roads which are which are going to be there in a city, small, in a plain area and all, or I'm talking about the roads which are on the regions where it's at a high altitude regions, or it is connecting the mountain ranges of Himalaya. So that kind of roads which we are talking about. So the movement of water through the soil mass may cause pavement failure. So the pavement, when there is a water which is, if the road is surfaced, and below the surface if there is whether it is having a soil which is easy to move the water, so the water which is moving through that area or just below the pavement will loosen the material, and that will create sinkholes in the sinkholes can be created in the roads. So seepage of water through mass of fractured rock of landslope or open cut may cause erosion or its failure. So sometimes the cuttings what you are making. So if you see in the video which is playing on the screen, so we can see that on the cutting edges on the screen, whatever the cutting edges on the screen, that all regions are falling down. So this is falling down. So if this the rocks which is on the sides are having a lot of fractures, then the water which will penetrate to that, and that will create failure of the failure of the road. So that kind of things can happen in the road construction. So highways or runways constructed in areas with water table close to the groundwater surface face problems of capillary water or seepage of water that reduces the strength of the structure. So it is very essential to provide the proper path for this water to escape in these conditions. So if you are going to do some constructions of road in this kind of terrains, it is very necessary that to provide a proper path for this water to leave leave the road, rather it should not get accumulated in that region. So proper drainages should be provided. Some amount of it should be there. There should be some layers which should easily remove this water from that region, and it should not allow the water logging in that road conditions. And if there is a water logging in that area, so it is going to be a difficult situation for the construction of the road. So the structures like the joints, the rock types, whether the rock is porous and permeable, whether the rock is having joints, or whether it is having the weak surfaces or weathered surfaces, these all parameters together decides the stability of a good road which you are going to construct in a terrain. So see this area. This is a road somewhere in Himalayan terrains where there is a landslide which has completely destroyed the road. Okay, so even the trucks which are moving on, what kind of road these trucks are moving on? So very difficult situations. Okay, so this is about the roads and soil. So now if you are talking about the tunnel, the groundwater bring about acute problems in tunneling. As far as the tunnel is dry, that is the most stable condition. But when we intersect the tunnel with the groundwater, for example, this is a proposed tunnel route. Okay, so if there is a groundwater table which is following some of this area, and then that means we are going to construct the entire tunnel in a groundwater region. Okay, so this is a very difficult situation, because when we do a small cut, the water from the saturated zone will enter into the tunnel. So there will be droplets of waters, or it may be a flooding of water which will be falling into that. So this is a difficult condition. So the best the possibility, if the water table is somewhere here, and if you are going to do the construction, that is the best condition. There is no intersection of groundwater table with our tunnel. But the situations arises something like this: when the water table is going to be intersected with the tunnel, the best possible methods what we adopt these days is the pumping. So what we do before starting the tunnel, what we do is that we do a borewell, okay, and then we'll start pumping the water from this area. So when we start pumping the water table will go down. Okay, so the water table, when it go down, then we do construct the tunnel, seal it properly, then stop the pumping. then again do other tunnel, other well, then do the pumping again, then bring down the water table below the project area or the project height, then do the tunneling, then stop the proper lining, then stop the pumping. So that kind of methods we adopt for in this kind of situations. Okay, so faults, if in some cases, if there is a area and there is a water table and this is a fault, so when you intersect the fault through this, all this water which is going to be flooding to the tunnel, so that again will create number of different difficulties. The problem is intensified when many times when the divisional planes are filled with water, a saturation with water weakens the shear strength of the rock. Okay, so such water zones in the structurally weak rocks if present in a tunnel may cause a collapse of the tunnel. So water which is presenting in this weak plane may leads to the collapse, because water is putting a lot of pressure on the weak planes, and if you are cutting some part of the rock, then the pressure which is already accumulated on that weak planes will be releasing its pressure through this collapsing of the rocks. Okay, the presence of underground water can be known by measuring the depth of water table along the tunnel alignment through boreholes, keeping piezometers at least for a year during the investigation stage. So what it is saying here is very important. At least for an year, we need to observe the water table change, that how the water table varies. Then we go for the process of constructing the tunnel. Then the groundwater study helps to decipher the nature of the probable water flow in the tunnel under the tunneling condition. It is not only the water but also those materials that may rush into the tunnel that are of great concern. Okay, so these are the basic activities of tunneling. Then in case of the water problems in the retaining structures, the configuration of water table and its relationship to the ground surface are very significant aspect in the construction of water retaining structures. The surface water percolates through unsaturated zone and reaches the zone of groundwater. But at places it comes at a seepage water or a gush out of spring, it gets an avenue through the ground. So even this kind of structures when we construct, this also needs to be studied, the characteristics, if there is a joints present. I remember one of my experience when I was working with the Institute of Seismological Research. We had a difficult issue. There is one factory somewhere in Baroda. They were having a water retaining structure, and that was their wastewater storage tank, something like this. They were having a water storage tank, and in this, what they used to do, the wastewater which is coming from the factory, they used to store it here for a period for the treatment. And it happened in something happened to this water storage. It was properly lined water storage, but something happened to this water storage, and the water from the wastewater from this area that get into the groundwater. So once it get into the groundwater, the people around the region, when they started taking water from their bore wells, they started getting the water from the bore wells which are of is something like the color of a Coca-Cola or Pepsi. So brown color water started coming from the water table or in the groundwater. So it is basically a leakage in this region, but that has totally contaminated the area. The whole region's water table has been contaminated by that pollution. So that kind of issues will come if you are not taking the proper care. So for that, we need to study the groundwater at what depth the groundwater is, whether there is a chance of intercepting this groundwater with the storage, whether there is any structural weaknesses, whether there is any joint, whether there is any fault, whether there is any weak planes through which this water can lead. Is there any chances of displacement or movement which can happen in that region, and it can create subsidence or it can create some breaks in the walls of the structure or the storage tank. So all that different things needs to be studied before going for the finalizing the location for this kind of water retaining structures.